Alright, welcome to our third video of Unit 6. This one we're finally talking about solubility. It's a very important concept, I guess. You don't really do a whole lot of math with it, but it's something that definitely should understand. So, let's get started. So solubility refers to the ability of one substance to dissolve into another. Two compounds are considered soluble if, when mixed together, they will dissolve into each other. For example, salt and water is definitely, we consider the salt soluble in water. We consider sugar soluble in water. We don't really consider a rock soluble in water. We don't really consider styrofoam soluble in water. Couple different examples. So the general rule of thumb is like dissolves like. Now, letting you know, this is not something you're going to need to focus on. You will need this in a later unit, and there's no reason to teach you this anywhere else, even in that unit. So pay attention, try to understand, but you have your objectives in their notes to focus on, and this is not one of them. So polar molecules will generally dissolve polar molecules, and nonpolar molecules will generally dissolve nonpolar molecules. We've talked about polarity before. We've talked about nonpolar with Lewis structures. And this is actually why many things will dissolve or won't dissolve in certain compounds. Maybe one is polar and the other is nonpolar. So we will look into this a little bit more in a later unit. But for now, like dissolve like refers to polar dissolving polar or nonpolar dissolving nonpolar. But again, that is not your focus for this video. It fits with this concept. So, two liquids are considered miscible. That's a semi-important word that a lot of people tend to forget, so please try not to, because it gets kind of annoying explaining all the time. So, miscible, if they're able to dissolve into each other, at least in various proportions. So, miscible basically is a fancy way of saying soluble, but it kind of takes it a little bit step further because it typically is when you're comparing two compounds. So water and salt, I don't really say they are soluble. I can say that salt is soluble in water, but you can't really dissolve water with salt. That doesn't really make sense. The term miscible, I can say water and orange juice are miscible, or miscible. Yeah, miscible. There we go. Miscible. Meaning I can dissolve water in orange juice, or I can dissolve orange juice in water. It's kind of, they're both soluble in each other. So that's the term miscible. And they're considered immiscible if they do not dissolve into each other, like oil and water. No matter how much I try, they're not going to dissolve into each other. Now again, this may come back to polar nonpolarness, but these terms are semi-useful. You'll focus more on soluble than miscible or immiscible. However, it's just terms that you want to keep in the back of your mind, kind of what they mean. So, in terms of solids dissolving, this is your focus for the video, because we have three main factors that affect our dissolving process: temperature, pressure, and surface area. Okay, let's figure out what they do. Temperature. Generally, an increase in temperature will result in an increase in solubility. And I have no idea why I'm telling you to go page 472. You totally know this. This is the factor that makes the most sense for you. This is why if you're making hot chocolate packets, you don't put them in cold water. It doesn't dissolve well. This is why you don't put powdered creamer, if you use powdered creamer for your coffee, in iced coffee. It doesn't go well. You know that as you heat things up, they tend to dissolve better. Now, interesting thing to note, that doesn't really apply for salt. Salt actually quickly hits a limit where it won't dissolve more. You can heat it up all you want, and you're not going to get much to dissolve. Sugar definitely will dissolve it higher, and it depends on the chemical bonds and all that stuff. But keep in mind that generally, not everything will increase solubility by temperature. But like 90% of things will. Pressure. Now, this kind of makes sense, but you just don't see it all the time. It says an increase in pressure will increase solubility of gases in liquids. Now, the easiest way to think of is a can of soda. Okay, this is supposed to be soda. And this is basically your liquid. Okay, your liquid contains all these different gas bubbles in it. And when it's sealed, you've got tons of pressure basically pushing down, keeping the gas in it. Almost think of like a bunch of bodyguards, making the gas bubbles stay in the liquid. However, as soon as you open the can, you've got this like sound that's like, wow, can't even do it. But the gas leaving, you hear it. And sometimes if you shake it up too much of the gas tries to come out at the same time, that it brings some of the liquid with it and you start foaming over. Okay, that's because you decreased your pressure. Your liquid's still there, but there's no longer that pressure. So the gas just escapes and leaves. Okay, that is basically what we're saying, is that as you increase your pressure, things will stay dissolved, at least gases and liquids, and as you decrease it, they're going to escape. So it's also not a really useful factor. If things aren't dissolving, you're probably not going to put it in a high pressure system. It's again more for carbonation, but like I said, you've seen it. It's just you don't normally use it. Last one though, this one's a little bit trippy, and I'm going to have to kind of show you a couple pictures. In general, an increase in surface area will always result. Wow, that was such a bad phrase. Let's cross out the word always. So in general, an increase in surface area will result in an increase in solubility. What this means is that the smaller the particle, the better it will dissolve. And you know this as well. You don't just take, wow, you totally know this. Like, you're trying to dissolve things in, you try to crush them, you try to stir it around, you try to break up the chunks of sugar or something in your drink. The thing that stumps people is how that's increasing surface area. Because they think of turning that into this and turning into, eventually this, basically. Like, let's pretend that was a giant block of sugar. Okay, you're not going to try and dissolve this block in your drink. It's just a chunk of sugar. It's going to take forever. You're going to start breaking it up, and you're going to break it into smaller sections. Then eventually, you're going to break it into basically a powder, and then it's probably going to start dissolving. Because the smaller the particle, the better it will dissolve. Here's the thing about surface area, though. This is what I mean by increase. Right here, the only real surface that things can react on is this outer edge, if you will. So, because, water is out here. It's not going to seep through. It's just going to react on any surface that it can. But right now, that's basically only these sides. Okay, as you break it up, now water can actually get inside. And as you get it smaller, water is basically all in. You're increasing the amount of space that can touch the water at any time. Now, what throws people is that this chunk has more surface area than this individual chunk. So people think you're making the chunk smaller, and yes, you are. However, notice we've got, like more chunks. So you end up having smaller but more pieces. It ends up where you are increasing your surface area, and you get to the point where as you keep crushing and keep making things smaller, more of the water or solvent is able to touch the solute, and it will dissolve better. So that's our last factor that affects solubility. So, last couple vocab terms. You'll probably notice this unit's a lot on vocab. So, a solution is considered saturated, very important term, if the maximum amount of solute has been dissolved in it. Now, here's a little weird trivia that actually is useful. Let's pretend that we both have the same amount of liquid. When people think saturated, they think, oh, we've only dissolved the maximum possible amount of solute. This is the type of solution they're thinking. Okay, and in this solution, let's pretend you got little particles down here. Most people would look at this and say, yeah, that's perfectly dissolved. That's probably saturated. This, they just didn't measure too well. So most of the time, however, that you see a solution where there's nothing on the bottom, like pretend we're trying to make sugar water, okay? If you see something where there's nothing down, it's probably what you're about to learn is called unsaturated. Because it is very, very, very unlikely that you put in only the exact amount of sugar that could have dissolved. Okay? That's highly unlikely. Typically, if there's nothing left at the bottom, it's going to be unsaturated. If you've got stuff left at the bottom, that's saturated. Because that means not only have you dissolved as much as you can, but you had a little bit extra just in case you're wrong, and this stuff's not dissolving. That means you've already filled up all the spots between the solvent and solute. This is saturated. This might be saturated, but 99% of the time, this is going to be what we call unsaturated. And what's interesting is actually when you look at this, some of these particles are going to be dissolving, but then particles in the solution are going to come back out. It kind of ends up, you dissolve as much as you can, and then kind of some of the particles continuously swap places. It's a state of called equilibrium. You'll learn very soon. But yeah, saturated is you've dissolved as much as you could. Okay, a solution that can have more solute dissolved in it, meaning there's still space, is considered unsaturated. And again, typically if you see just a clear solution, that's probably unsaturated because saturated is typically indicated by stuff being left on the bottom. Lastly though, if it contains more than normal possible, it's considered supersaturated. So this would be like if you took a solution that looks like this, so it's saturated, and let's say you heated it up such that somehow you got all that stuff to dissolve. This would be saturated. This would be supersaturated. This is what happens when you make proper sweet tea or when you make rock candy. You basically heat up the water. You can dissolve more sugar. And when it cools down, it's still dissolved, but more has been dissolved than what really should be possible. That's called supersaturated. And that actually is our video. Thank you for watching. Again, remember the 3 factors that affect solubility, and remember the difference between saturated, supersaturated, and unsaturated. Thanks for watching.